Exercise 3.8 is going to be our first attempt at sorting data with a computer program. So we are going to have a first exercise here that is relatively easy, which is I read 3 integer value from the user. So I'm going to comment this in as I go over the exercise and what we have to do. Read 3 integers from the user. Then we are going to have to sort the 3 integers, let's say in ascending order. So the first integer will be the smallest one. Display sorted integers on the screen. That's the 3 main steps of our program. Okay, so the first step is relatively easy. Okay, scanner s equal new scanner. I'm creating a new scanner object here based on system.in, and I'm assigning a reference to it to the variable s, which is declared here as capable to hold a reference to a scanner object. Then what? Then we need to read those 3 integers. So I'm going to go ahead and do a system.out.print enter first integer, okay, which is going to be followed by s does next int to read the integer, and I'm going to store this in a variable I will call nb1, number 1. Okay, so I have my scanner, I have the code to read the first integer. Let's move ahead. Ask the user for the second integer. Store it in a variable which we are going to call nb2. And then go to the end here. And then we have just to take care of nb3, which is going to be our third integer. Okay, little delay here. Third integer stored in variable nb3, and there we go. So we are done with this part. Okay. Now we are going to sort the 3 integers and display them sorted. Well, displaying them sorted is going to be a matter of doing a system.out.println, and I'm going to display something such as first integer is now plus the value of nb1, and I'm going to do the same thing for integers number 2 and integer number 3. So let me go back here and modify the code I just cut and pasted. I'm displaying the 3 variable, and I'm going to say the second integer is now nb2, and the third integer is now and the current value of nb3. Okay, so what's happening here is that you give me 3 value for nb1, nb2, nb3. Okay, and then I'm going to figure out which one should go first, which one is the smallest one, and then move to nb2, determine which one is the smallest one, and move to nb3, determine which one is the smallest one, and put it there. So nb1 would be the smallest of the 3 when I'm done, nb2 would be the one in the middle, and nb3 would be the biggest. So how do I go about to sort those 3 numbers? Well, first I save my program, I go back to Conqueror, and I'm going to compile and make sure that what I wrote so far is okay. So exercise 3.8 compiles fine. Let's try to run it now. Enter your first integer. Okay, 9, 2, and 33. First integer is 9, the second is 2, the third is 33. Well, we didn't sort much, but at least our program is working. So I'm clearing the screen, going back to my code. Now I need to figure out how to sort. Well, okay, let's take a piece of paper here and figure out what we have to do. We have 3 integers so far. Okay, so this is going to be my first variable, nb1, nb2, nb3. Okay, nb1, nb2, nb3, 3 int variable. Well, let's take a concrete example, and let's get rid of that pesky little window there. Let's take a concrete example. I was given the number 30, 9, and 99. Well, how can I go ahead and sort those 3 numbers? Well, if I want to sort my array in ascending order, I want the smallest one to be in nb1. How do I figure out which one is the smallest one? Well, first I check is NB1 actually smaller than NB2? My purpose is for NB1 to be the smallest, okay? So first check, is NB1 smaller than NB2? Well, in this case, no. So what do? Swap them. What if NB1 was actually the smallest? Well, nothing to do. It's the smallest, it's in the first slot, that's fine. Then what do I do next? Well, the next question is, what about NB1 and NB3? Is NB1 smaller than NB3? No, I swap them. In my case here, with the example I took, the answer is yes. I have nothing to do. And then finally, what else do I need to do? Well, I'm pretty much done with NB1. I compared it to the first integer, I compared it to the last. So when I'm done with those two statements, I made sure NB1 is actually the smallest of the bunch. What is left to do? Well, I'm going to be in this situation here. Okay, I'm going to have NB1 equal to 9, NB2 equal to 30, NB3 equal to 99. That's the example I took, okay? So with my two tests, I just decided to swap NB1 and NB2. Now I need to check what? I need to check about NB2. Is it at its right position or not? Well, this entails checking if NB2 is lesser than NB3. I don't need to check NB2 compared to NB1 anymore, because I already did that. So if NB2 is lesser than NB3, well, nothing to do. If it is not, then I'm going to swap them. Okay, so in addition to what I have up here, I have a total of 3 tests to do to make sure that those 3 integers are actually in ascending order. So I'm going to implement this now in my little program. So I'm going back to the code itself. Here it is, and I have like 3 statements to implement. Okay, 3 conditional statements. The first one was if NB1 is actually lesser than NB2. What was my logic? I have nothing to do, so I'm not going to go with this. I'm going to say if it is actually greater than, then I have something to do here. My second test was if NB1 still is greater than NB3, then I should swap them. So this is what I'm going to do here. Last possibility, if NB2 is actually greater than NB3, then I have to swap those two numbers. So I left the code right now empty for the swap part. Okay, this is how you write your code. You write your code with a skeleton that you then complete. So if NB1 and NB2 are not in the right position, I need to swap them. How do I swap the content of variable NB1 and NB2? Well, I need a temporary variable. I need something I'm going to call int tmp. That's going to hold temporarily the value of one of those guys. Okay, let me show you exactly what I'm talking about here. When I want to swap, for example, let's take our same example, NB1, NB2, NB3. If I decide that NB1 and NB2 need actually to be swapped, okay, I have a value like 39 and 99 here. If I want to swap those two values, I cannot just write NB1 equal NB2 and then NB2 equal NB1. Okay, why I cannot do this is obvious. When I execute NB1 equal NB2, what's going to happen? Well, what's going to happen is that NB1 content is actually replaced by the value inside of NB2, 9. And once I'm done evaluating this line, you see that I lost completely the previous value of NB1. So when I write NB2 equal NB1 here, I'm assigning 9 here, which is, well, still 9, and I lost a value. Instead, what I need to do is proceed with a temporary variable. Let's call it tmp, okay? And what I need to do is tmp equal NB1. I save the value of NB1, so NB1 was 30, let's say, tmp is now 30. Then NB1 is assigned NB2. I overwrite 30 with 9. Which is okay because I saved the value 30 somewhere else. So once I'm done, NB2 is overwritten by the value in tmp, which is 30. End result, I needed an extra variable, but there we go. I did my swap between the two variables there. So let's go back to the code. I'm going to use a variable tmp. Okay, and as I indicated in my example, tmp is going to be equal to, well, let's say nb1. I want to swap nb1 and nb2. Then nb1 is going to receive the value of nb2, and nb2 is going to receive the value of tmp. Okay, and this is it. This is a code that's going to swap the first two value, nb1 and nb2. What if I want to swap instead nb1 and nb3? Well, I can reuse the same code, okay, and then I can modify it. tmp is nb1, nb1 is nb3, and nb3 is finally tmp. What if I want to swap nb2 and nb3? tmp is going to be equal to assigned nb2, then nb2 is going to be assigned nb3, and finally nb3 is going to be assigned tmp. So once I figure out the logic to make one of the swap, I can fill in the blank for all of those different conditionals. Okay, going back to Conqueror, let's see if I introduce some typo there or syntax errors. No, we're good. Now let's try to run this and figure out if it's running correctly. I'm going to make this window a little bigger. Enter the first integer. Well, we use the example, what was it already? It was, I have a blank. Let me go back and figure this out real quick. It was 30, 9, and 99. Okay, so 30, 9, and 99. 9, 30, and 99. Well, okay, now to establish whether our program is really working, we need to think a little harder. What's going on here? We can swap the first two integers, okay, to determine which one is the smallest. Then we swap the first one and the last one. Then we swap the middle one and the last one. So I would like to have enough diversity in my test so that I can establish that this program is working, no matter what was the initial order of my array. So here's what I tested so far. I tested so far 30, 9, 99. Which value you choose is irrelevant. What matters is that in this example we had an array in which the first element was in the middle, what should be the second element was to its left, and what should be the third element was to the right. Well, let's try to be a little bit more systematic. Okay, so we are going to test the following cases. We are going to test an array that is already in order. So that's going to be 9, 30, 99. Or I could use even 1, 2, 3. Okay, then I'm going to test what? I'm going to test an array that is in disorder, with the first element being in the middle, with the first element being last. Okay, and then I can keep generating. I could generate all the permutation. Okay, I'm not necessarily going to do that, but what I want to point out to you is that yes, if you want an exhaustive test, you would have all permutation, and if you want just to verify, for example, that your first number is going to be found, whether it is in the first slot already, second or third, you would do this way. Okay, then I can start generating variants of those examples. For example, 1, 2, 3. Well, let's try 1, 3, 2. So I'm still testing. My first element is there, but I make all variants that are possible with the remaining two elements. Same thing here. Okay, my first element is in the middle, but I'm going to try with 1, 2, 3 and 2, 1, 3 and 3, 1, 2. So I permutate the other possibility. What about the last one? Same thing. 3, 2, 1. Okay, so that gives us a bunch already of values to test. 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 1, 2, 2, 3, 1, 3, 2, 1. And you see what kind of logic I followed when I designed these test cases. So let's go back to, not the code, but let's go back to actually Conqueror. And I'm going to test these different cases. So I'm going to run my code, and I'm going to use the number 1, 2, 3 for sake of simplicity. So if my array is already ordered, it's still ordered when I'm done sorting it, which is always good news. Now, assuming 1 is still in its place, I'm testing 3 and 2. 1, 2, 3, my sorting works. Now let's say that 1 is in the middle place initially. 2, 1, 3. 1, 2, 3 is the output. Let's try 3, 1, 2. Other possibility with 1 in the middle. Output is 1, 2, 3. what is left for me to try? 2, 3, 1. 1 is at the last slot, still sorting successfully. And then 3, 2, 1. 1 is still at the last slot, the other two have been inverted, and we are still sorting correctly. So pretty much at this point this code is correct.